In this video, we are going to talk about the calculus, which is useful for the physics students. So the purpose of making this video is to make you understand how the calculus is useful in the subject of physics. So I will be keeping my discussion very focused to only those topics which are important for physics. Otherwise, calculus is so large, so many topics are there that it's very difficult to cover the concepts of calculus within few hours, right? So I will try to keep my session very precise, and I'll be trying to cover most of the topics which are useful for physics in this. So when we talk about calculus, we are going to talk about two things in calculus. One, we are going to talk about differentiation, and the other thing which we are going to talk about is integration. Okay, so I'll start with the differentiation. Now, as we already know, that if we want to find out the slope of a line, say I want to find out the slope of a line, we make the axis, I make a line, and I want to find out the slope of this line. So the method which we use is we take 2 points on this line. Say the coordinates of these 2 points are x1, y1, and the other coordinate is x2, y2. Then to find out the slope, we use the formula y2 minus y1 over x2 minus x1. So this is going to give me the slope. Okay. Now, for the straight line, it is very straightforward that you use this formula. But the problem arises that instead of having a curve something like this, we have something like this. Now in this case, if you try to find out the slope using the 2 points, and if I join these 2 points, so the slope, which we again use the same formula, say y2 minus y1 over x2 minus x1, so this slope will not be the slope of the curve, but it will be the slope of the dotted line, which is joining these 2 points. So we cannot find out the slope of the curve by this method. Instead, what we do is we bring the 2 points so close to each other that they are almost overlapping. And how can we do that? Say we take a point over here, and we take another point in the vicinity of the first point, and I join these 2 points. Now as you can see that these 2 points, even though these are 2 different points, but still they are so close that the line which I make is not cutting the curve, but it is just touching the curve. I bring these 2 points more close so that the gap between these 2 points decreases by a large amount. So the 2 points will be so close to each other that their x values and their y values will be almost same. They'll not be exactly same, but they'll be almost same. In that case, if I try to find out the slope by using the normal method, that will give me the slope of this particular line, which here in this case is called as the tangent, right? So if I do so, and I said just now that y2 and y1 will be very close to each other, similarly x2 and x1 will be very close to each other. Let me just try making it. So this is x1, this is x2. The gap between x1 and x2 is very small, In the same way, if I try making the points y1 and y2, they will be somewhere here, and the other point will be very close to it. So y1 and y2. In this case, the change in y and the change in x, these are very small. So we can say that change in x is approximately equal to 0. Similarly, change in y is also approximately equal to 0. Instead of writing like this, we will represent it in a different way. So change in x is approaching to 0 and change in y is also approaching to 0. When this happens, the slope is written as dy over dx. So dy is very small change in y. Similarly, dx is very small change in x. Okay, so here comes the point. The value dy by dx is the slope of the tangent made on the given curve at a given point. Okay, so this is what we mean by differentiation. This is the meaning of differentiation, dy by dx. We write it as, we spell it as derivative of y with respect to x. This is how we speak dy by dx. I hope this thing is clear to all of you. Alright, now if this thing is clear, let us try to write down few formulas based on the derivatives. Now the derivative of x to the power 0. Now x to the power 0 is what? X to the power 0 is 1. So this can also be written as derivative of 1, right? This thing will be 0. So I can generalize it here. The derivative of any constant c will be 0. So this is my first formula. The second formula which we use is derivative of x to the power n is given by n x to the power n minus 1. Then derivative of sin x is cos x, and derivative of cos x is minus sin x. So these are few formulas which we are going to make use of in solving the numericals in physics. Of course, there are many more formulas, but they will not be very useful for us. But here I would like to add something. This sin x is the basic function. When we are finding the derivative of sin x, it is cos x. It's a very basic function. But in the applications which we are going to work with, they will be having a number written next to x. Like for example, if I say find out the derivative of sin 3x, right? Now it's a different function altogether, because in this case the angle is not x, the angle is 3x. So if the angle was x, then the derivative of sin x would have been cos x. We have seen the formula above. But in this case, since the function is sine 3x, not sine x, so the answer is going to be a little different. How? Let's see. So if you try finding out the derivative of sine 3x, this would be 3 times cos 3x. Now you might be wondering why this 3 is coming into picture. Again, I'll not go into detail how we solve this kind of question. But for now, just try to understand that if I have any function other than x, like I had sine x, the derivative of sine x is given by cos x, as we have seen this formula above. If I have anything other than x, anything, so we simply, instead of writing the answer straight away, we write it. Okay, so instead of x, we have anything else. Let's assume that I want to find out the derivative of sine elephant, right? I told you, anything other than x. It can be anything. It can be elephant, it can be Ashish, it can be anything, right? So sine of this thing will be cos of the same thing which is written in place of x, but we are going to multiply this answer with the derivative of elephant. Let me give you an example for this. Say I want to find out the derivative of sine of 3x. Okay, so instead of x we have 3x. Let me call it as elephant, right? Sine of 3x, sine of elephant. Here elephant means 3x. So the answer would be cos of whatever is written in the bracket, the angle, multiplied by the derivative of whatever was written in the bracket. This would be cos 3x into 3. Derivative of 3x is 3. Okay, so this would be 3 times cos 3x. Let me give you another example. Say I want to find out the derivative of sine of x square plus 2x plus 1. It's a very complex function. So instead of x, we have x square plus 2x plus 1. Again, the method remains the same. Sine of any angle other than x will have the derivative as cos of the same angle. But since it's not a simple angle, it's not x, it is x square plus 2x plus 1. So we multiply this whole answer with the derivative of the angle. So this is going to give me cos of x square plus 2x plus 1 into derivative of x square plus 2x would be 2x plus 2. So the final answer becomes 2x plus 2 cos x square plus 2x plus 1. Now here I would like to add one more thing. Some of you might write it as cos of the product of these two, which is incorrect. The reason is x square plus 2x plus 2, this is the angle. So cos of this angle, whatever you get, multiply that thing with 2x plus 2. So 2x plus 2 is not the part of the angle. Okay, so this is what we generally do mistake in. Alright, so this was one of the example. Let me give you another example. So before I give you more examples of the trigonometric functions, let me give you an example of the normal polynomial functions. Say derivative of x to the power 3, right? Now we know the formula. The general formula says that derivative of x to the power n is n times x to the power n minus 1, right? Here in this question, n means 3. So 3 times x to the power 3 minus 1. So this gives me 3x squared. Okay. Similarly, if I have the derivative of x to the power 8, then the answer would be 8 times x to the power 8 minus 1, which is 8x to the power 7. As simple as that. Okay. If I have something like derivative of 3x square plus 5x plus 2, right? Now if you have the three terms added together and we are trying to find out the derivative of this, so this would be derivative of 3x square plus derivative of 5x plus derivative of 2. Okay, so I separated the three terms. Now this can be written as 3 times derivative of x square plus 5 times derivative of x plus derivative of 2. Now we already know the general formula which we used in some numericals before. So if I apply this formula here, so this gives me 3 times 2x plus 5 times 1, derivative of x is 1, plus, now 2 is a constant, so derivative of 2 would be 0. So this gives me 6x plus 5. Okay, so this is how we solve any kind of polynomial functions. I'll give you one more example of a trigonometric function. Say we have derivative of cos 5x. Okay, so in this case we will write, now if you have the derivative of cos x, that is minus sin x. In this case x is replaced by 5x, so the answer will be minus sin 5x. But the answer doesn't stop here, we have to multiply this with the derivative of 5x. So this gives me minus 5 sin 5x as the answer. Okay, so I hope these questions are clear to all of you. In case you have more doubts, we can discuss it during our sessions, right? All right, before I end the topic of derivatives here, I would like to tell you one more concept which we call as, it's not a concept as such, but there can be a scenario where the function y is not a single function, but it is the product of two or more functions. In that case, say we have two functions as u and v, right? So we have two functions u and v, and I want to find out the derivative of this y. It means finding the derivative of u into v. Now if you have a scenario something like this, so what we do is we find out the derivative of the first function and we keep the other function intact. Okay, let me write it like this. So we write v times derivative of u. So we find the derivative of u, whatever is the result, we multiply it with v, plus u times derivative of v. Okay, as simple as that. Let me give you an example for this. Say I want to find out the derivative of x square sin x. Now as you can clearly see here that there are two functions, x square and sin x, and these are being multiplied, and I am trying to find out the derivative of the product of these two functions. So in this case what I'll do, I'll keep one of the function intact, say sin x, and I will find out the derivative of the other function, plus I'll keep the first function intact, x square, multiplied by the derivative of the other function. Alright, and we'll simply put the values. So derivative of x square is 2x, so this will become 2x sine x, plus derivative of sine x is cos x, so this becomes x square cos x. This is the answer. Another example, derivative of x square plus 2x into cos x, right? Now for this, let me call this function as u and this function as v, right? And we already know how to find out the derivative of u into v. So this would be v, which is cos x in my case, derivative of x square plus 2x plus u, which is x square plus 2x, times derivative of v, which is cos x. So this gives me 2x plus 2 times cos x plus minus sin x into x square plus 2x. Now final answer can be 2x plus 2 cos x minus x square plus 2x times sin x, right? So I'll stop my discussion over here for the topic of differentiation. I will bring on another video on the integration part in some time. Thank you.